Airbus and Boeing manufacture aircraft that perform similar missions. They cross oceans, transport millions of passengers, connect continents, and compete for the same contracts. However, behind their white fuselages, high-efficiency wings, and gigantic engines lie two opposing philosophies. Each company has developed a distinct way of deciding who should have the final say in the air, how a pilot should be trained, how a cockpit is designed, how fuel consumption is reduced, and how to win a commercial war worth hundreds of billions of dollars. For much of the 20th century, Boeing represented the industrial might of the United States. The company grew in a country with a gigantic domestic market, vast distances, powerful airlines, and a military industry that propelled technological advancements at an extraordinary pace. World War II left behind an immense aeronautical infrastructure, factories trained for mass production, engineers accustomed to solving extreme problems, and a culture where aviation was part of the nation's strategic muscle. That legacy profoundly shaped Boeing. The company learned to build resilient, scalable, and commercially dominant
The integration
aircraft.
of these designs
its large
is
bombers
critical to
demonstrated
maintaining our
industrial
strategic
capability,
advantage.
and later its civilian aircraft transferred that expertise to passenger transport. The Boeing 707 ushered in the era of the intercontinental commercial jet for many airlines. The 747 transformed the scale of air travel. Suddenly, a single aircraft could carry hundreds of people between continents with an image of technological power that was hard to match. Boeing grew as a company already at the top. Its challenge was to maintain its leadership, improve successful products, and respond to airlines with profitable aircraft. Its logic was cumulative. Each model built upon what came before, each improvement leveraged a proven foundation, and each decision aimed to reduce business risks. This continuity became one of its greatest strengths and, over time, also a source of rigidity. Airbus was born from a completely different situation. Europe had great aeronautical traditions, but its manufacturers were fragmented. France, the United Kingdom, Germany, and other countries were developing their own projects, often technically brilliant but too expensive to compete against the American scale. While Boeing, Douglas, and Lockheed dominated much of the international market, Europe watched its factories lose ground. The creation of Airbus was an industrial and political response. Several European governments understood that no single country could challenge the power of the United States in commercial aviation. The solution was to build an international consortium, divide tasks among countries, concentrate resources, and accept that the primary objective was survival. Airbus was born as an act of European integration applied to one of the most complex industries on the planet. This origin explains many subsequent differences. Boeing designed from the security of an established company. Airbus designed under the pressure of demonstrating that Europe could still build competitive aircraft. Boeing could afford to evolve. Airbus needed to surprise. Boeing sold accumulated confidence. Airbus had to offer a clear advantage to convince airlines accustomed to buying American aircraft. The first major European breakthrough came with the A300, a wide-body, twin-engine aircraft designed for high-demand routes without reaching the size of the jumbo jets. Its appeal was economic rather than symbolic. Fewer engines meant lower fuel consumption, less maintenance, and more efficient operation. Airbus understood that the battle against Boeing could be won with a simple idea: offer airlines an aircraft that reduced costs. This mindset continued to grow. Boeing came from a culture where the pilot and the machine maintained a physical, direct, almost mechanical relationship. Airbus moved toward a culture where the aircraft became a fully digital system. The difference was no longer just in the size of the fuselage or the range. It lay in the most profound question of all: when an aircraft enters a critical situation, should it obey the pilot without restriction, or should it prevent the pilot from pushing it beyond its physical limits? That's where the true separation began. The cockpit of a commercial aircraft reveals much more than a layout of instruments. It is a statement of trust. It shows the role of the pilot, the power of automation, and how each manufacturer understands the relationship between humans and machines. For decades, Boeing maintained a philosophy centered on pilot authority. Its cockpits retained the traditional yoke, a large control column in front of each seat. This element seems simple, but it carries enormous symbolic weight. The pilot moves the yoke, feels resistance, observes the co-pilot's control movement, and maintains a physical sense of control. Even as modern aircraft incorporate advanced electronic systems, Boeing has maintained an interface that conveys continuity with previous generations. This philosophy stems from a fundamental idea: the pilot must be able to intervene decisively. Automation assists, warns, stabilizes, and protects, but the human being retains ample room to act. In extreme situations, that ability can be crucial. A thoroughly trained pilot can interpret an emergency in a way that no algorithm could have predicted. They can improvise, prioritize, shut down systems, use accumulated experience, and guide the aircraft to a possible outcome under imperfect conditions. Airbus developed a different approach. For the European manufacturer, safety also means preventing human error from taking the aircraft outside its flight envelope. The flight envelope is the set of physical boundaries within which an aircraft can operate safely. It includes minimum speed, maximum speed, angle of attack, structural loads, and other essential parameters. Airbus has transformed that envelope into a digital boundary protected by computers. The A320 was the symbol of that revolution. Its arrival introduced a fully digital fly-by-wire architecture to single-aisle commercial aviation. Instead of transmitting the pilot's movements via cables and mechanical rods, the aircraft interprets electrical commands, processes them in flight control computers, and translates them into precise movements of aerodynamic surfaces. The human hand no longer directly moves the aircraft. The human hand requests an action, and the system calculates the best way to execute it within safe margins. The most visible change was the sidestick. Airbus replaced the central yoke with a small side lever. At first glance, it seemed like a minor element, even strange to many pilots trained in traditional cockpits. In reality, it represented a radical change. The aircraft ceased to resemble a machine governed by physical effort and began to feel like a high-precision digital system. The Airbus philosophy is summarized in a powerful idea. The pilot commands the trajectory, the computer protects the aircraft. When the system is operating under normal conditions, the computers apply control laws that prevent maneuvers capable of causing a stall, excessive speed, or structural overloads. If the pilot pulls hard on the sidestick, the aircraft interprets the intention to climb but limits the maneuver to preserve safety. If a command threatens stability, the system adjusts the response. This approach generated intense debate. Some pilots admired the precision, stability, and protection. Others perceived a disturbing gap between the human command and the aircraft's final reaction. In Boeing, the feeling was more direct. In Airbus, the feeling was more filtered. This difference fueled an almost philosophical rivalry for years. Boeing placed more trust in the pilot's final judgment. Airbus placed more trust in an architecture designed to prevent the pilot, under stress, from crossing dangerous boundaries. The technical reality is more complex than any caricature. Boeing also uses advanced automation. Airbus also allows flight law downgrades where the pilot is given greater manual responsibility. Neither manufacturer builds simple aircraft. Both integrate redundant layers, multiple sensors, strict procedures, and rigorous certifications. The difference lies in the design priorities. Boeing traditionally preserved a more familiar control interface and more visible human authority. Airbus normalized a more digital relationship between pilot and aircraft. That difference carried over to training. At Boeing, each model retained its own characteristics. A 737, 777, or 787 pilot recognizes a common manufacturer logic, but each type requires specific adaptation. At Airbus, the company strongly emphasized commonality. The A320, A330, A340, A350, and A380 families share cockpit principles, automation philosophies, and procedures that facilitate transitions between models. For airlines, this is of enormous value. Less training time means more operational flexibility, lower costs, and crews that are easier to reassign. The cockpit, then, became a commercial tool. Airbus sold fleet efficiency and reduced training costs. Boeing sold continuity, familiarity, and confidence in proven platforms. Both propositions made sense. Both addressed real needs. and both took the rivalry to a level where engineering, economics, and pilot psychology became completely intertwined. The difference between Airbus and Boeing is also evident in airline offices. There, the future of thousands of routes, millions of passengers, and contracts that can sustain factories for decades are decided. A commercial aircraft is purchased for its price, but also for its fuel consumption, maintenance, availability, training, resale value, technical support, financing, and compatibility with the existing fleet. Boeing dominated this field for decades because it offered something invaluable: commercial reliability. Its aircraft were proven, its maintenance chains were global, its spare parts circulated worldwide, and its models had accumulated millions of flight hours. For an airline, buying Boeing meant integrating into a familiar ecosystem. This trust acted as a barrier to entry against any new competitor. Airbus had to aggressively break through this barrier. Its first challenge was perception. Many airlines viewed the European consortium as a political experiment, a complicated alliance between countries with differing interests. The manufacturer needed to demonstrate that it could deliver reliable aircraft, provide global technical support, and sustain programs for decades. To accelerate adoption, Airbus offered highly competitive commercial terms, attractive financing, and agreements that reduced risk for customers. European industrial policy also played a role. Airbus received state support at various stages of its development, particularly through repayable loans and financing structures that the United States criticized for years. Boeing, for its part, also benefited from military contracts, public research, tax incentives, and a deep relationship with the American aerospace industry. For decades, the commercial rivalry spilled over into international organizations, where each side accused the other of receiving unfair advantages. Beyond the legal disputes, Airbus found an extraordinary commercial weapon in the cockpit community. An airline operating several Airbus models can move pilots between families with less friction than in highly heterogeneous fleets. That detail changes the day-to-day economics. In aviation, every hour of training, every simulator, every rating, and every crew booking costs money. A design that simplifies this internal network becomes a competitive advantage. Boeing responded with its own strength, a massive installed base. Thousands of pilots were already trained on Boeing aircraft. Thousands of technicians were familiar with its systems. Many airlines had hangars, spare parts, and procedures adapted to its models. Changing manufacturers involved hidden costs. That's why the continued production of the 737 was so important. The 737 family became one of the most successful aircraft lines in history because it allowed airlines to renew their fleets without completely disrupting their operational ecosystem. This point highlights a crucial difference. Airbus was prepared to introduce technological disruptions to gain ground. Boeing tended to extend successful platforms to protect its customers from abrupt changes. Airbus proposed a leap toward a common digital logic. Boeing proposed an evolution on a known foundation. Both strategies had advantages. The former could accelerate modernization. The latter could reduce adoption risks. The battle became especially intense in the single-aisle segment, the world's most important market. Aircraft like the Airbus A320 and the Boeing 737 support thousands of short and medium-haul routes. They are the heart of traditional airlines, low-cost carriers, and regional networks. Whoever dominates this segment controls a decisive part of the future of commercial aviation. Airbus managed to consolidate the A320 family as an extremely attractive alternative. Its modern cabin, efficiency, and commonality allowed it to grow in markets where Boeing seemed untouchable. Boeing defended the 737 with successive upgrades, new versions, engine improvements, and a constant promise of continuity for existing operators. For years, that competition was balanced, fierce, and highly profitable for both companies. But the competitive pressure also produced dangerous incentives. When every percentage point of consumption matters, when every month of delay can hand contracts to the rival, and when every program costs tens of billions of dollars, companies face a constant temptation to stretch out old designs, accelerate certifications, promise minimal training, and present updates as simple changes. In that arena, the rivalry between Airbus and Boeing ceased to be an elegant competition between engineers. It became an extreme test of corporate culture. At the beginning of the 21st century, Airbus and Boeing made opposing bets on how the world would fly. That difference resulted in two iconic aircraft, the Airbus A380 and the Boeing 787 Dreamliner. Airbus envisioned a future dominated by major hubs. According to this vision, air traffic would continue to concentrate in gigantic airports like London, Heathrow, Paris-Charles de Gaulle, Frankfurt, Dubai, Singapore, and Los Angeles. Congestion would increase, slots would become ever more valuable, and airlines would need to move as many passengers as possible on every landing and takeoff. The logical answer was an immense, double-decker aircraft capable of transporting extraordinary numbers of passengers between major international nodes. The A380 was a technical marvel. Its size demanded new structural solutions, complex hydraulic systems, adapted airports, special doors, reinforced aprons, and continental manufacturing logistics. Giant components traveled from various European countries to Toulouse, where the final aircraft was assembled. The program reflected the European dream of surpassing Boeing in the symbolic arena that the 747 had dominated for decades. The largest, most imposing, most recognizable aircraft in the world. Boeing chose a different path. The company bet on a future of point-to-point routes. Instead of transporting enormous numbers of passengers between hubs, the 787 would allow for direct connections between secondary cities with lower fuel consumption and a more modern cabin experience. Its key lay in the extensive use of composite materials, efficient engines, advanced electrical systems, and a structure designed to reduce operating costs on long-haul flights with fewer passengers than a super jumbo. The contrast was striking. Airbus opted for concentration. Boeing opted for dispersion. Airbus built a giant for giant airports. Boeing built a more flexible aircraft for leaner networks. Airbus envisioned the future as a network of major hubs. Boeing saw it as a web of direct connections. The market ultimately favored flexibility. The A380 worked very well for specific operators, especially Emirates, which built part of its model around Dubai as a major global hub. However, many airlines found it difficult to profitably fill such a large aircraft year-round. 4 engines meant greater complexity and higher costs in an era that rewarded the efficiency of long-range twin-engine aircraft. The aircraft offered a spectacular passenger experience and a powerful image for airline brands, but its economics depended on very specific conditions. The 787 also faced serious development problems. Boeing suffered delays, cost overruns, production difficulties, and initial battery-related failures. Even so, the core idea of the program aligned with the evolving market. Airlines were looking for efficient aircraft capable of opening direct routes with less risk. An aircraft with less capacity than an A380, but with long range and relatively low fuel consumption allowed them to test new routes without depending on massive demand. The story of the A380 and the 787 reveals a profound difference between Airbus and Boeing, but also an irony. Airbus, the company associated with digital efficiency and operational precision, opted at that time for a monumental machine. Boeing, the company of tradition and continuity, opted for a radical structure in composite materials and a more flexible air network. The rivalry was never a simple opposition between conservatives and innovators. Each company has been bold and prudent at different times. The commercial end of the A380 taught Airbus a harsh lesson. An aircraft can be technically brilliant but economically limited. Engineering can solve the problem of making a giant fly, but the market decides whether that giant fits into the real network of airlines, airports, and passengers. Boeing won that particular strategic gamble with the 787, although it paid a high price in industrial complexity. Meanwhile, Airbus found a quieter revenge with the A350, a long-range, efficient, twin-engine aircraft also built with composite materials. The A350 demonstrated that Airbus could compete in the new era of modern widebodies without relying on the extreme size of the A380. Boeing kept the 787 and prepared the 777X as the successor to its historical long-haul strength. The duel remained open, but the market's center of gravity was now clear: efficiency, flexibility, and lower operational risk. However, the gap between Airbus and Boeing reached its most critical point with the 737 MAX. This episode encapsulated decades of competitive pressure, platform continuity, low-cost promises to airlines, and internal tensions within Boeing. The commercial origin was clear. Airbus launched the A320neo, a more efficient version of its A320 family with new engines and aerodynamic improvements. Airlines reacted strongly because fuel represents one of the largest operating costs. A percentage savings on thousands of flights annually can mean millions of dollars. Boeing needed to respond quickly to protect its customers and prevent a mass migration to Airbus. The cleanest option would have been to develop a completely new aircraft. That decision required many years, a colossal investment, and enormous commercial risk. Boeing chose to upgrade the 737 again. The result was the 737 MAX, equipped with larger, more efficient engines. But the 737 is a platform with old roots, designed in an era when engines were smaller and the aircraft sat relatively low to the ground. Integrating modern engines into that architecture required adjustments to position and design. These changes altered certain handling characteristics under specific conditions. To maintain a piloting feel compatible with previous versions and facilitate certification as an evolution of the 737, Boeing incorporated MCAS, a maneuvering characteristics augmentation system. Its function was to move the horizontal stabilizer to help lower the nose in certain high angle of attack scenarios. The problem was the combination of design, certification, information, and training. The system initially relied on data vulnerable to sensor misreading. Its existence and behavior were insufficiently integrated into the operational awareness of many pilots. Following the Lion Air 610 crash in 2018 and Ethiopian Airlines 302 crash in 2019, the world discovered that a solution designed to preserve continuity had created an unprecedented crisis of confidence for Boeing. The impact was enormous. The 737 MAX fleet was grounded worldwide. International regulators reviewed procedures, software, training, and certification. Boeing faced investigations, lawsuits, colossal costs, and profound reputational damage. The company that for decades had symbolized robust engineering and industrial dominance became associated with an uncomfortable question. To what extent had commercial pressure displaced technical authority? This episode is often presented as a moral victory for Airbus, but the more accurate interpretation is different. The 737 MAX revealed the risks of a culture that relies too heavily on continuity when the technical environment demands a major break. Boeing tried to protect the familiarity of the 737 and avoid training costs for airlines. That strategy had worked for decades. With the MAX, it reached a critical limit. Airbus has also faced accidents, failures, controversial decisions, and problematic programs. Commercial aviation is an industry where every manufacturer lives with extreme risks. However, the MAX case struck Boeing at the core of its identity because it affected precisely what the company had promised for years: a safe, familiar, and controlled evolution. The paradox was profound. Boeing had built part of its reputation on pilot authority and resistance to overly intrusive automation. The MAX ended up trapped in a crisis caused by an automated system whose logic and scope were insufficiently communicated. Airbus, for years criticized for placing computers between the pilot and the aircraft, was positioned as a company whose automation was more deeply integrated within an explicit and well-trained philosophy. The case transformed the relationship between manufacturers, regulators, and airlines. It also reinforced the idea that modern safety depends as much on engineering as on transparency. A system may function technically, but it needs to be understood by those who must live with it in an emergency. On a commercial aircraft, software, training, documentation, and corporate culture are all part of the same safety system. Today, Airbus and Boeing remain two indispensable giants. The world needs both. Airlines rely on these two main suppliers to avoid even greater concentration. Airports, supply chains, lessors, engine manufacturers, and regulators all operate within a delicate balance where every move by one affects the others. Airbus enters this stage with a very strong position in the single-aisle market. The A320neo family continues to be in high demand, and the A321neo, especially in its long-range versions, has opened routes that previously required larger aircraft. This model has become a strategic tool for airlines seeking transcontinental or transatlantic flights with lower capacity and better economics. Airbus has managed to transform a single-aisle aircraft into a platform capable of challenging even segments traditionally served by smaller wide-bodies. Boeing retains essential strengths. The 787 remains a cornerstone of modern long-haul aviation. The 777 maintains a significant presence on high-capacity routes, and the future 777X aims to renew that position with greater efficiency. The 737X, following modifications, regulatory reviews, and its return to service, continues to receive orders because many airlines already have Boeing ecosystems and need efficient single-aisle aircraft. Global demand for aircraft is so large that even a company battered by profound crises retains a central role. The difference lies in perception. Airbus projects an image of commercial stability and a single-aisle product advantage. Boeing projects an image of recovery, regulatory vigilance, and cultural rebuilding. That perception matters a great deal in an industry where contracts are signed for 20 or 30 years. An airline buys aircraft, but it also buys future confidence. Spare parts, deliveries, support, upgrades, residual value, and public credibility. The supply chain adds another layer. Neither manufacturer builds an aircraft entirely in a single factory. Engines, avionics, landing gear, fuselage sections, composites, electrical systems, and thousands of other components arrive from global suppliers. A delay in a single part can halt deliveries. A quality issue at one supplier can affect entire programs. Airbus and Boeing compete, but both rely on a vulnerable, distributed industrial network under enormous pressure. The environmental transition is also pushing them in the same direction. Airlines need planes that consume less fuel, generate fewer emissions per passenger, and can be adapted to sustainable fuels. Airbus is exploring hydrogen concepts and future architectures. Boeing is investing in efficiency, sustainable fuels, and incremental improvements. The next major revolution is still open. The commercial aircraft of the future could require new engines, longer wings, advanced materials, superior automation, and perhaps a disruption comparable to the arrival of the jet engine. But the central mystery remains. Airbus and Boeing look at the same sky and see different problems. Airbus tends to think in terms of common systems, digital security, integrated families, and operational efficiency. Boeing tends to rely on continuity, accumulated experience, large platforms, and a long-standing relationship with pilots and airlines. These tendencies have changed over the years, but they remain as cultural imprints. The difference also appears in how each company responds to failure. Airbus learned from the A380 that technological pride can outweigh real market need. Boeing learned from the 737 MAX that commercial pressure can erode essential technical decisions. Both lessons are costly. Both belong to the same industry truth. In aviation, success never depends on a single innovation. It depends on aligning technology, market, regulation, training, maintenance, and corporate culture. That's why Airbus and Boeing are so different, because their airplanes carry within them the history of the places that created them. Boeing represents the evolution of an industrial powerhouse that dominated the skies and learned to extend successful platforms for generations. Airbus represents the ambition of a Europe that decided to unite to compete and turned integration, digitalization, and commonality into commercial weapons. Their differences are evident in the cockpit, the controls, the software, pilot training, the way they finance programs, and their route strategy. They are also evident in their mistakes. Airbus failed when it believed the future required ever larger airplanes. Boeing failed when it stretched a platform too far to respond quickly to a rival. One company erred on the side of monumental vision, the other on the side of continuity. Modern aviation exists within that tension. Every time a passenger boards an A320, a 737, an A350, a 787, or a 777, they enter a design philosophy. The seat looks similar, the window shows the same sky, and the destination may be the same. But beneath the floor, behind the cockpit, and within the software, two industrial histories continue to compete. Airbus and Boeing are different because they never tried to solve the same problem from the same place. One was born to challenge supremacy, the other to maintain it. One built its identity around common digital systems, the other around continuity, scale, and piloting tradition. And although their aircraft are becoming increasingly similar due to the demands of physics, fuel, and regulation, the rivalry remains because, at its core, both manufacturers represent two opposing answers to the same question: how should the world fly?